Back at functional programming and linking. We're on chapter 1.4. So the last time we basically just tried some stuff out, got started in the language. Like I said, I've made it up to 1.6 before. So I'm going to be redoing everything from the start. This time we're going to start on 1.4, see how far we get. And hopefully we get back up to 1.6 so I can get to some new material. But yeah, let's just get into it. And I'm also going to be changing a few things up from the last video. One of them is I'm going to go through it like I go through books whenever I'm trying to learn something, especially if they have exercises. So I'm going to be incorporating a little bit of the theory of learning how to learn in there. And if you haven't heard of that Coursera course or the book, um, I definitely recommend that. Check it out. It really will change how you learn things, how you structure, how you learn, how you understand yourself and how you learn. So yeah, check out Learning How to Learn. I'm not going to be incorporating all that stuff, of course, but I'm going to be doing a few things that I didn't do the last time that I usually do when I'm reading books. Um, for example, just to go through them, the first thing I usually do in a new chapter, this is something that I really should have done in the first place, but whenever I'm starting a new book and I'm starting a new chapter, if they have summary sections, whether that summary section is at the end of the chapter, or sometimes they'll have it at the beginning of the chapter, and sometimes it'll be both. Like they'll have something to prepare you for what you're going to learn, and then they'll have a review section at the end. So the first thing that I usually do when I'm starting a new chapter, just so I can get sort of familiar with what's going on and I can prepare my mind to intake a certain type of information to um, kind of pre-expose myself to the information so it's not as new and as novel the next time I see it. That way I can incorporate the concepts a little bit deeper than if I was seeing it for the very first time. Um, so I did this off camera already, but usually what I would do is read the summary. So just reading through all of these little sections here, you don't necessarily have to understand everything. When you're reading through the summary section, I wouldn't focus on understanding. I would focus on key words, key patterns. What is it that the author is trying to bring to my attention? So I'd probably look at the stuff about functions. I'd look at the different notation, see what the similarities are, see how they're different. Um, Read through whatever they have going on here. And I'm going to be doing this section, so let me actually take some time to reread this. Brand new data types can be introduced in Lean using structures or inductive features. So this is how we're going to define our own data types, which is very important in math. Um, these new types are not considered to be equivalent to any other type, even if their definition is otherwise identical. Structures of Lean are not the same. Okay. See, and I don't really know what that means. And like I said, that's perfectly fine when you're reading the summary. Maybe they'll explain it later on in this, maybe they won't. And next time we read the summary, when we get to the end of the chapter, we might look it up instead of just going over it like we're doing this time. Let's jump into it. All right, so the second thing that I usually do that you're going to start seeing me do more as I'm going through this book and other books and papers in the future. Should almost drop my pen. Um, it's just scanning through, and like I said, you don't have to understand it. You're just trying to kind of prepare your mind for what's going on. Maybe read some of the code, read the headlines, the first sentence or two. And then there's a word that we just saw in the summary section with the constructor. And then this is also very important. Reading the exercises, and because you haven't learned the material, because you haven't actually read the chapter yet, you're not really going to know what to do with those exercises or how to solve them. That's perfectly fine. You're not trying to prove you're some super genius by being able to answer the exercises before you even see the material. Like reading the summary was, this is just a method to review the material and prepare your mind for what's going on. So something we're going to have to do is define a structure called a rectangular prism, height, width, depth, of where each of the elements, height, width, and depth, is a float. So that's sort of similar to what we did with the volume thing before, and we can see that with this second part here. Define a function named volume that takes regular rectangular prism to a float. So basically, we're going to want to put in the height, width, and depth, and reduce that to one number that's a float, and that's going to be the volume of that rectangular prism. Define a structure named segment that represents a line segment by its endpoints, and define a function length that takes segment to float. So once again, pretty similar to the rectangular prism. Uh, Calculates the length of the line segment. Um, and so for these two, even though, if you know the material, you don't have to do it again, but it's always good for you to double check and look up the formulas for these things. Look up, the mathematical notation for how line segments are represented, and how subtraction is represented within those number systems, because you're going to need to know that stuff in order to build what it's asking to answer the question. Which names are introduced by the declaration of rectangular prism? I don't remember what that means. Which names are introduced by the following declarations of hamster and book? What are their types? Okay, so a declaration isn't a type. That'll be interesting to know. Maybe that'll be relevant later. But yeah. So, so let's get started on this. First step in writing a program is usually to identify the problem's concepts and then find suitable representations for them in code. Sometimes a domain concept is a collection of other simpler concepts. In that case, it can be convenient to group these simpler concepts together into a single package, which can be given a meaningful name. In Lean, this is done using structures, which is analogous to struct in C or Rust, and records in C sharp. Okay. Let's try out, the first thing it's showing us is floats. Let's try some of those out. So check 1.2, it's a float. Okay. Yeah, I just believe that. So when it's written with a decimal point, Lean will automatically infer that it's a float. So let's go here and try that out. So nat by itself is, or zero by itself is a nat. Uh, yes, so zero is a float. Alright. So let's try the same thing with integers. -1 is an integer. 0 is a float. It checks out. Feature point is a structure with two float fields. Let's try that out. Well, let's just type it out. So structure point where x is a float, y is a float, Deriving rubber. See, is that supposed to put? Yeah. Okay, just have it in. See, we're fucking. That's what we're fucking up. I'm sure that will mean something. So, a second. Rep stands for representation, like generated representation. I'm not sure. Let's try to look it up. My computer will. Hmm. Let's double check that. You don't want to. Get to this. We'll get to this one later. It's finally quick versions. So that's the follow. That's type points. Right. I fucking up yet again. What was that? That's what it means. See if we get that error that it's mentioning. It still works. I think that happened last time also. Um, could be something to do with the update. Oh, hold on. That's one. We gotta try and keep it out over. Sure. Yeah, the should add points. You want to type points. Output type points. So then that specific concept. Square brackets. So nice. Gotcha. So that's this one. Wonder if you can change it to the right type without defining it. It's just define the function you want. if I would like, I don't know what to do about that. Furnace. And all. Oh, okay. I just said building. Yes. Bracket do I use in defining the points? I think the curly. Yeah. So define zero, it takes a point, turns a point, and we're gonna replace maybe p with x, zero, and x. So this dot notation is actually interesting stuff. Okay, this one's confusing me a little bit. Let's try to break it down. It's gonna be a float to this. Okay. I don't know why it took me so long to realize what this was saying. Kind of embarrassed. So, modify both is a function defined for the structure points, where we have two things going here. One is a function that takes a float to a float. The other one is a point P in the structure points, and it takes the function and the points, and it outputs another point. And so what you're doing, x is going to be the function applied to point x, y is going to be the function applied. So what we're doing here, come down to eval. Our point is going to be 4 and 3. We're going to do the function, modify both. And modify both needs us to input a function that's going to be float floor. And it's going to apply it to fpx. So the floor, what was it? 4 and 3. The floor of x is 4. So y is 3. So we got that. That's pretty cool. Let's try these exercises. Let's see if we can get some of those out for the hour mark. What's 20 minutes? Let's go with here. Indian structure name where. This. Oh, I'm sorry. So let's see how we want to do it. Some full brackets.
Well, all right, you get her nice but hey man, I would love to see you man and more right about it. Talk to too. She's loves me after seeing my friends now. So you're welcome to come by, you know, once you like me. I got a I have a few. That's okay. I'll let you know when I'm headed home. And also, I have a few beers I want from work. Just got a couple of minutes. Oh. Here's just